Welcome to day 12 of my AVR Advent Calendar. In this series of videos I show you in 24 days how to program the AVR 8-bit microcontrollers. So let's see what's inside the paper bag number 12. Okay, here we go. So this is a variable resistor, and the AVR microcontrollers have various ways to interfere with analog voltages, because we will use this variable resistor to generate various analog voltages. And one way is the analog comparator, at which we will take a look today. So let's take a look at the datasheet, and here we can see the analog comparator is just an analog comparator. So we have two pins, the analog input 0 and analog input 1. Here we have a comparator, and according to the two voltages, this analog comparator output will be 0 or 1. This pin here is fixed, but this analog input 1 pin here, so we can choose if we want to use this analog input 1 pin or if we want to use a pin from our analog digital converter input pins. And we can select or we can generate interrupts over this analog comparator, and here we can select on which event the interrupt should occur, and we can turn on or off the analog comparator over this switch here. So that's basically it. And so now let's see where these analog input pins are. So here is the pinout of our Mega 88PA microcontroller. And we see here we have analog input 0, and here we have analog input 1. And if we want to use a multiplexer, we could use any of these pins here instead of analog input 1. Okay, so how can we use this comparator? Well, it's quite easy. So here we have analog input 0, and I will connect two resistors of the same size to it. So one goes to 5 volts, the other one is connected to ground, and this will lead, we have a voltage level of 2.5 volts here. And with my variable resistor I can generate a variable analog voltage here, and this pin here of the analog of the various resistors goes into my analog input 1 pin here. And I will want to control this LED, so depending on the variable resistor, this LED will be turned on or turned off, depending if the value is over or under this 2.5 reference voltage. Okay, so let's take a look at the registers we have to program to use the analog comparator. So here is the ADC control and status register B, and if we want to use the multiplexer for using another pin than analog input 1, we have to set this bit, and we have to set the analog ADC multiplexer, but we will talk about this in another video. Today we will just use the analog input 1 pin, so we can set this bit here to 0. And here we have the analog comparator control and status register, and here are some important registers. For example, bit 5 is our analog comparator output, so here we can read the current state of our analog comparator. If we want to turn off the analog comparator, we have to set bit 7, which is analog comparator disable. And bit 3 and 4 are for the interrupt, so with bit 3 we can enable the analog comparator interrupt, and with bit 4 we get the interrupt state. And here bit 0 and 1, over these two bits we can select the analog comparator interrupt. So by default both values are set to 0, and this means comparator interrupt on output toggle, so when there is a change on the analog comparator output, the pin will toggle. And if we set it to 2, we will get an interrupt on the falling output edge, and if we set it to 3, we will get an interrupt on the rising output edge. Okay, so with this knowledge we can start programming. So let me cd into my AVR Advanced Calendar folder. I will copy this number 9 crystal here, and I will create a new folder I will call 12 analog comparator. Oh, and of course I have to give it the -R option. So let me cd into this folder, and let's run a clean. Okay. And instead of blink here, I will use AC for analog comparator. Okay. So let's edit the main function. So here we are initializing part B pin 0 for an output for driving our LED here. This is correct. Now let's init the analog comparator. What I will do here is I will in the analog comparator status and control register, there should be ACSR. I will just enable the interrupt, and in the ADC status register B I will set to 0 because I don't want to use the multiplexer, and with say I will enable the global interrupts. The while one loop here can stay empty. Okay. And up here I will use the interrupt service routine. The vector is analog comparator vector. So, and here I will check if the analog comparator status register, if the bit analog comparator output is set, then I will turn my LED on. Okay. And if not, oh, I forgot a brace here. If not, I will turn my LED off. Okay. And very important, up here I have to include A4R/interrupt for the interrupts. Okay, so let me try to compile this program. Okay, compiling works, so let's flash it. So we want to write our analog comparator.hex. I will give it the password. Okay, and now I will take my screwdriver. Oh, I haven't connected it yet. Give me a second, I will do the connections. Okay, you can see I've done the connections. I've added these two resistors of the same size to give us a reference voltage of 2.5 volts. And here I have my analog comparator. If I have a value bigger than 2.5 volts here, the LED will be turned off. And if I adjust the value with my screwdriver, and if I go under 2.5 volt, the LED will be on again. Okay, cool. So this was the first way to handle analog inputs. On my next video, we'll talk about another way to use analog inputs. So that's it for today. I hope you've enjoyed the video and learned something. Thanks for watching, and I hope I will see you tomorrow. Bye!